Okay, so if not, I'd like to bring our Roy online. Roy
Hello.
here.
Yes,
Hi, Roy.
I'm here. I'm here. Yes.
How's it
everybody.
doing?
Yes, I'm fine. I'm fine. I'm very much looking forward to explain a little bit about the new trends in power measurement. And I'm very happy that so many people have joined the event already, and the numbers are still going up, I think.
Yes.
So yes, I think that everybody is geared up to to start the event.
Right. I can see the numbers are increasing as well. So anyhow, so let's not take up too much time. So over to you, Roy, Singapore connecting to Netherlands. All right.
Okay.
So
all right. Yes, I will share my screen for my presentation. So there we go. I hope that everybody can see the screen. Yeah, of course, officially welcome everyone. And Kevin, thank you very much for the introduction. As already mentioned, my name is Roy Hali. I'm a product marketing specialist at Yoki Europe and responsible for supporting our sales and customers in all different kind of applications. And therefore, yeah, we have prepared also this presentation because we are at the stage of introducing a new power analyzer. And with that power analyzer, we can handle yeah, new generation power measurement. And that's what we like to introduce to you. So this webinar will address some challenges in power electronic device measurement and system measurement, and also give the solutions to those challenges. And if we start with the main concept of this presentation is the designers are using more SiC and GaN semiconductors nowadays. But why are they doing that? What makes them so interesting? And what is required to accurately measure the loss and efficiency of SiC and GaN-based applications? And that's what we are going to address in this presentation. Well, to explain this, I would like to go talk about the ongoing development of electrical vehicles. It is clear that car makers are in a constant process to increase the range of their cars, to reduce the charging time, and to cut manufacturing costs. As a part of that, they bring out regularly new software updates to improve the temperature measurement of the battery or to tune the electrical drivetrain. On the other hand, there's also a constant development going on for the hardware within EVs. A downsizing of the powertrain is therefore an interesting application. As you can see here in the center, we see a assembly of a inverter and the electrical motor and the reducer. And this kind of compact assemblies is more and more becoming the standard in installing in EVs. One of the larger and more heavy parts in the inverter is the step-up reactor that you can see here, and a picture here on the right-hand side. It has a considerable size because it has to be able to handle the power that is required by the EV powertrain. The power that the step-up reactor can handle equals omega L, where omega represents the rotation frequency and L the inductance. So if you want to reduce the size and weight of the inductance L, it is needed to increase the rotary frequency omega. And this can be done by increasing the switching frequency of the semiconductors in the motor and regenerator bridges that you can see here on the slide. Well, SiC and GaN semiconductors can operate at higher switching frequencies and have less switching loss than traditional silicon IGBTs. All this together makes it possible to design smaller, lighter, and more efficient inverters with SiC and GaN semiconductors. Downsizing also gives engineers more freedom in their designs and reduce the use of copper, a very popular raw material. In a nutshell, this explains the popularity of SiC and GaN semiconductors. There is, however, also a downside to this story. It's much more difficult to measure power accurately at high switching frequencies, like 100 kilohertz or even more. Why do you think that is? I would like to explain that in the next few slides with some challenges that are presented by this. The first challenge that we face is the interference of phase error. I like to explain this with the two phase diagrams on this slide. On the left side, you see the vector diagram of a device with a high power factor, for instance, a power resistor. In this case, the influence of the power error, the red area, is very small in comparison with the measured active power. However, when we look at the right-hand side, we see that the power error is very big in comparison with the measured active power. And therefore, as soon as you're going to measure at low power factors, it's extremely important to compensate for the phase error. So how can we achieve that? First, I will explain why all power measurement systems are influenced by phase errors. The equation for real power is shown here. To be able to measure the power accurately, it's necessary to measure the voltage, the current, and the power factor accurately. Generally speaking, the measurement of the voltage is quite simple because almost all the power measuring instruments have a direct input for the voltage measurement. The current measurement is different, however. All different current measurement methods create phase errors. Internal shunt resistance, for instance, have a low resistance and are by nature inductive, which makes them unattractive for high frequency measurements. And as we have seen earlier, the trend in power electronics is to increase the frequency and to make downsizing and improved efficiency possible. Hioki is predominantly using external current sensors that have a 2-volt output voltage for the nominal input current. This type of current sensors will cause a phase error, as you can see in this frequency diagram. The red curve shows that already from about 10 kilohertz, there is a noticeable phase error, and therefore you might consider that this current sensor is not a good solution for high frequency power measurement. But that's not really the case. Let me explain you why. The design of the Hioki current sensors guarantee a constant frequency characteristic. In other words, all the current sensors that have the same model code will have identical frequency characteristics. With this in mind, we can work out a method to eliminate the phase error. All new current sensors that are suited for power measurement have an internal memory in which the model code, the current range, the phase error information, and the serial number are stored. When the current sensor is connected to the new PW8001 power analyzer, it will be recognized automatically. And all the relevant information, like the phase error, model number, serial number, and rated current, will be registered in the PW8001. Here you see two screenshots of the PW8001. Here on the left-hand side, you can see that the instrument has recognized a CT6846A current sensor, which has a range of 1000 amps for AC and DC. And this has a serial number, which is shown here at the bottom. At the same time, you can see here on the right that the instrument has set the phase shift correction automatically, meaning that the phase errors are being compensated for the full frequency bandwidth of the power measurement. We call this automatic phase shift correction, APS-C, and it's a plug-and-play solution, unique in the power measurement market of today. The second challenge that the increase of frequency has created is the influence of high switching frequency noise. To explain this phenomena, I like to go back to the reactor loss measurement. On this slide, you see a typical circuit to measure the reactor loss of a device, where you can see here a current sensor and the voltage measurement. When we look here at the center of the slide, we see a screenshot of the instrument, and at the top we see a switching voltage, a square voltage, with a frequency of 100 kilohertz. And that frequency is realized by switching this semiconductor hard. Due to this hard switching of the semiconductor, there will be high frequency interference at the frequency of 100 kilohertz and its harmonics. And when we look at the current measurement through the reactor, we see here at the bottom, where we use an ordinary current sensor, that all these frequency interference, so the switching noise which is created by switching the semiconductor, is measured by this current sensor. And this is, of course, not a good solution to measure your power accurately. There is, however, a solution. As you can see here, the yellow trace, E1. This is measured with the CT6904A current sensor, which has a common mode rejection ratio of 120 dB or more at a frequency of 1 megahertz. The 120 dB common mode rejection ratio is equivalent to 1 ppm or less interference of noise at 1 megahertz. In other words, yeah, you can just neglect the influence of noise at higher frequencies with this kind of current sensor. This example shows that it's not sufficient to just use a power analyzer with a high common mode rejection ratio. Your current sensor needs to have an excellent common mode rejection ratio as well. The third challenge that I like to mention is the signal strength of the current signal when it is necessary to use external current sensors. Our main competitors, they rely on third-party suppliers for their current sensors. They normally use current sensors that have a current output, and they connect the current sensors to the internal measurement shunt of the power analyzer. This is different for Hioki. We develop and produce the power analyzer and current sensors ourselves. Let's take a look at an example. In this example, we measure a current of 100 amp. For this, we need to use an external current sensor. The CT6873 has a range of 200 amps, and it will generate an output voltage of 1 volt when it's measuring 100 amp current at the input. If we look at one of our known competitors, the situation is as follows. The 200 amp sensor will generate an output current of just 200 milliamps when it's measuring an input current of 100 amp. The current output is then connected to an internal shunt that has a resistance of just 80 milliohm. The generated voltage at the input of the power analyzer, in this case, will only be 16 millivolt. Yeah, if we compare that with the 1000 millivolt or 1 volt that the Hioki solution is providing, it becomes clear that the signal at the input of the PW8001 is 62.5 times higher than at the input of the other power analyzer. You can imagine this has a huge impact on the signal to noise ratio for your current measurement. The fourth and last challenge that I would like to mention is the increase in system voltage. We have seen different applications where the system voltage and especially the DC voltage is increasing. The first one being the industrial solar farms. we see now that the standard voltage is around 1500 volts DC. And yeah, that is producing some issues because there are some changes in regulations, which I will mention later in this presentation. The reason why they increase the voltage is that they want to have more efficiency and more power out of a solar farm, and in that way be able to reduce the production of solar energy, the price of solar energy. Another situation where we see an increase of the system voltage is the development of electrical buses and trucks. If you know, the general cars, EVs on the market are using at this moment a 400 or an 800 bus system. But now when we are looking into the trucks, the more power is required, and therefore truck makers are looking at 1200 volt DC as a battery voltage. And to be able to to manage this, we have here an example of a dual drivetrain power system. You have to be able to measure the DC of 1200 volts accurately and according to the standards. The internal safety requirements for electrical equipment for measurement control and laboratory use described in the IEC 61010-1 edition 3.1 will become effective from the 1st of January 2022. That date, from that date on, it's not sufficient any longer to use equipment that complies to previous versions of this regulation. A test laboratory inside a factory is considered to be a Cat 2 environment. So to be able to develop and test the earlier mentioned applications, it's necessary to use a power analyzer that can measure up to 1500 volt in a Cat 2 environment, and that complies to the latest edition of the IEC 61010 edition 1 standard. The PW8001 is the only benchtop power analyzer at this moment on the market that is IEC 61010-1 edition 3.1 compliant, and therefore can be used also after the 1st of January next year to measure up to 1500 volts in a Cat 2 environment. Okay, let's go to the next slide. We have seen some challenges and solutions of today's power measurements. Now let me introduce some features and technologies behind it. The new Hioki flagship power analyzer, the PW8001. The PW8001 has a 10.1 inch touchscreen and can handle up to 8 input channels. There are 2 different types of input modules, the U7001 and the U7005. Later in this presentation, I will address more details about those units. The basic accuracy of the PW8001 at 50 to 60 Hertz is 0.03% and 0.05% for DC measurement. The highest sampling frequency is 15 megahertz, and the AD conversion has a resolution of 18-bit. It can measure up to 1500 volts in a Cat 2 environment, compliant to the latest IEC standards. In combination with the latest generation of current sensors, it has automatic phase shift correction function, APS-C. This unique feature reduces the setup time and eliminates phase errors, regardless of the frequency and power factor that the instrument is measuring on. As I mentioned earlier, there are 2 different input modules available. The U7001 high voltage input unit and the U7005 high accuracy input unit. You can see, you can freely select them and combine them in a random order in the PW8001. If we take a closer look at the U7001 input unit, we see that it can measure up to 1500 volt DC in a Cat2 environment. And it has an accuracy of 0.077% for DC and 50 to 60 Hertz. The sampling frequency is 2.5 megahertz and the bandwidth is 1 megahertz. These specifications make these units very useful for DC and grid-related measurements. It further can be used for IGBT-based inverters measurement, like solar power conditioners, and that all for a very moderate price. The other unit, the U7005 high accuracy input unit, with its base accuracy of 0.03 at 50 to 60 Hertz and a sampling frequency of 15 megasamples per second, and a power bandwidth of 5 megahertz, is developed for the evaluation of SiC and GaN-based products and give a better result at low power factor measurements, like reactor measurements of inverters drives that we mentioned earlier in the presentation. Then if we look at the options that are available at the release of the release date of the instrument, we have basically two options available from the beginning on. The first one is the power and 4-motor analysis function. It enables engineers to measure the mechanical power of the drives at 4 different locations. In this application, you see a performance EV where there are 4 in-wheel motors, and it's very useful to be able to measure the mechanical power of each of these motors to be able to tune the whole system of the car. And therefore, it's a very useful option, but not only for this application of a performance EV, but also for other applications. You can think, for instance, about drones or the development of industrial robots, where also multiple motor drives are involved in one system. The second option that is available on the PW8001 is the waveform and DA output function. This function provides a possibility to output your voltage and current signals in a waveform output with a sampling frequency of 1 megahertz, and it's therefore useful to monitor the shape and the events on your voltage and current signals for a longer time. It can be combined with an analog output, which basically is a trend information of the measured RMS values, as you can see here at the bottom. And the update interval for that is the same as the update interval of the display, and can be then at a minimum 10 milliseconds for the update rate. So when you are interested in long-term characteristics of your system, it might be interesting to connect these signals to a high-performance memory recorder, for instance, like the MR6000 of Hioki, and then you can get a long-term saving of your values and waveforms of the voltage and current, and use that for later analysis. As already mentioned, the current sensors are an essential part of accurate power measurement. Together with the PW8001, Hioki is introducing a range of new current sensors. The memory inside the sensors make automatic identification of the current sensor and automatic phase shift correction possible. This feature reduces the setup time and minimizes the chance of measurement errors due to phase shift error and scaling errors. For applications where traceability is important, it is interesting to know that the serial number of the current sensor can be logged in the measurement file as well. Here you see the overview of the pass-through current sensors. This type of current sensor provides the highest accuracy and bandwidth. I like to point out, especially the CT6872 and 6873, which both have an accuracy of 0.04% of the reading and 0.008% of the full scale. This is very, very good. And they also have an exceptionally high bandwidth. So for the 50 amp version, the bandwidth is 10 megahertz. And for the 200 version, it's 5 megahertz. And these current sensors have been designed especially to measure for SiC and GaN applications. So where your switching frequencies is 100 kilohertz or even higher, these are really the right sensors to be used. Although you might think that clamp-on sensors are not the right fit to be used in combination with this high-spec power analyzer, we think that the clamp-on sensors in the CT6840X series are worthwhile to consider. Their basic accuracy is 0.03%, and the wide operating temperature of -0 to +85 degrees Celsius makes them popular, for instance, for WLTP tests of vehicles with an electrical drivetrain. Also, the evaluation of solar power conditioners where the bandwidth is not any issue, the clamp-on current sensors can be considered. Let's take a look at the applications where the PW8001 can be used in. We start, of course, with 8-channel applications because the instrument has 8 channels, and that's quite unique in the market. On the left-hand side, you can see a dual drivetrain of a performance EV. In this application, the DC measurement at the input of the inverter can be done with the U7001 input unit. When in future the voltage would exceed 1000 volt DC, this input can also be still measured then. For the inverter output, however, it's necessary to use the U7005 because of the high bandwidth and accuracy that is essential for the high frequency measurement. On the right-hand side, the development of a multifunctional solar management system is shown. In future, this kind of systems will become more advanced and complex. At this moment, probably when you have a solar panel, the solar panel will be connected to the inverter, and the output of the inverter will be directly connected to the grid, and your energy will be saved in the grid. In future, however, we think that the grid will not be able to handle all the different inputs of solar power, and therefore there will be an increase of battery storage, electric battery storage, and in future, when there are more EVs on the market and people are buying them in higher quantities, and especially in sunny regions as the Southeast Asia, it might be that also the solar panel power is directly used and to charge the car without converting it first to an AC voltage and then again to a DC voltage in the vehicle itself. So there is a possibility to increase the efficiency of a system like this. And then if you look here at the different points where you have to measure power, it's very useful to have an 8-channel power analyzer. For this application, 8 times the U7001 is sufficient. Another application which was already mentioned is the SiC and GaN DC converter and inverter drive development. In those kind of applications, there are reactors involved. And as we have already discussed, the automatic phase shift correction function in that kind of measurements is very, very high rewarded and essential to have an accurate measurement. So for this kind of application, the high automatic phase shift correction is important, the high accuracy at DC, but also the high accuracy at 50 or 100 kilohertz is very important. And the instrument is also excellent performing at that high frequencies. Further, the update rate of 10 milliseconds is important because then you get more information about the dynamic behavior of your system. Here we see a dual drivetrain application as well, where we use DC inputs and we can measure up to 3 channels or the input phases of the motor, and also at the same time the mechanical power at the X of the motor. And in this kind of situations is more and more becoming important because the development of automated vehicles for distribution centers and that kind of things, but also for, of course, situations in electrical vehicles where performance is required. In this case, also the automatic phase shift correction function is important, and the high-speed sampling of the instrument, of the high update rate of the instrument. Another application where this instrument is very, very suitable is wireless charging. Wireless charging, the standard frequency, the standing switching frequency of wireless charging is 85 kilohertz and therefore very high. And therefore it's important to have a system that can measure at these high frequencies. And especially in this area, you will need therefore the U7005 input module combined with the high-end current sensors. For the 50 to 60 hertz, it's good enough to use this U7001, and also on the DC side of, for instance, the vehicle, it's also good enough to use the U7001 input module. In this application, noise resistance is very important. And of course, the automatic phase shift correction, because you have to select all kind of inductive components and you want to make sure that the loss of those are within your limits. And then to measure the accuracy or the efficiency of your system, it's not only important to be accurate at low frequencies, but also at high frequencies. And the PW8001 has a 0.2% all over in accuracy for power measurement at 50 kilohertz, and that's very important. Another important thing is the IEC harmonic analysis, because this system will be connected to a grid, and therefore you have to make sure that the system is not generating too much harmonic distortion when it is connected to the grid. So our mission is to provide true power analysis for engineers in pursuit of power conversion efficiency. The PW8001 power analyzer and the new current sensors will be released in the middle of December. For more information about this product, please visit the PW8001 landing page. And that concludes my presentation, and therefore, I would like to go back to Kevin to check with him if we have already any questions. And let me go to the controls and stop sharing my screen. Yeah.
Thanks, Roy. And that was a very insightful sharing from. I think we saw how you explain about the challenges the 4 different challenges that is coming up in the power management systems. And after that, I think we also heard from you about the solutions from Hyogi. Now, ladies and gentlemen, feel free to post your question and answer. I think we can give you some time to digest the information that Roy has mentioned. At this moment, my colleague Jesse is actually sharing with you some of the brochures of the power analyzer PW8001. We are also sharing with you a special landing page on the product. So feel free to take a look on that. All right, we have a question here. That's a very good question from Johnny. I think Johnny is from Singapore. Roy, so that was actually from chat. So ladies and gentlemen, remember to post your question on Q&A so that it's easier for us to monitor. So anyway, I saw from Johnny's question, Roy, could you explain what's the technical differences between PW3390 and the PW8001?
Well, the main difference, of course, is that the PW8001 is basically a modular platform where you have the choice of 2 different input modules. And depending on the application that you have, the sampling frequency of the PW8001 is much higher. So in general, you could say that if you are involved in SiC and GaN applications, then it's better to use a PW8001 because it has a higher switching frequency and a higher bandwidth as a power measurement. And that's what you need in that kind of applications. And the PW3390 is a compact, lightweight solution that is very often used in measurements of DC or grid or IGBT-based drivetrains, and also very often used in the field. So in that respect, you can it's difficult to compare them even, the 2 instruments. But yeah, for applications like WLTP, most of the customers are using a PW3390, and for the high-end, how do you call it, high-end research and development, the PW8001 is the better fit.
Right. In fact, what Jesse, my colleague Jesse, is sharing with you on the brochures about PW8001. In this brochure, you will be able to find the technical comparison between PW8001, PW6001, and PW3390. So if I were to say the good, better, best, the PW3390 maintains at the good level, where the PW8001 far exceeds all the existing good benefits of our power analyzers now. In fact, PW8001 is the best power analyzer that we have at the moment. In fact, it has also the highest number of channels. You heard from Roy, 8 channels as compared to the other 2 power analyzers. On top of that, we really need to understand your applications before we can actually advise further. Just to add on to Roy's point, the SiC and GaN technology is a very new technology. It's a developing technology. So what Hyogi has foreseen, we actually plan in advance for the engineering industry. There are already industries that's using the SiC and GaN semiconductors. So this PW8001 will be a very good power analyzers for them to analyze the power situation of the semiconductors. So in summary, we really need to understand your application before we can advise further. And at whether is at Europe or whether it's in Hyogi, Singapore, if you would like to find out more how this PW8001 can work together with your application, you can contact either Europe or Hyogi Singapore. We have the demo units with us, which we can actually bring down to test on your system and to see if we can actually get the desired parameters that you need. All right. Okay, we have 2 more Q&A here. So this is from George. Okay, so Roy, from George, on the first application slide for EVs, the measurement setup is 2 times low BW modules and 2 times high BW modules. What are the 2 low BWU 7001 modules measuring?
If I understand correctly, they are measuring the both on the battery side. They're measuring the DC voltage of the drivetrains. So in that measurement, it's not necessary to have the high bandwidth, and also the accuracy of the input module of 0.07% is already good enough to measure accurately your DC measurement voltage or power, DC power. And by just selecting this input module, also you have an excellent measurement, but also it has an effect on the total cost of your test system, because the input module, the 7001, is considerably lower priced than the U7005 with his high bandwidth and high sampling range. Yeah.
Okay, I hope Roy answered your question. George, if there's anything that you need to clarify, you can post in the Q&A again. Another point, this is from Harano-san. We have our Japanese colleague with us here. So Harano-san has gave us a good news. So he mentioned that at the point of the printing of the catalog, the correct frequency for CT6873 200 ampere is 10 it was 5 megahertz, but it is actually 10 megahertz. So
okay.
Yeah, so thanks Harano-san. So anyway,
Yeah.
I believe the new catalog that I've sent is the latest one. So ladies and gentlemen, please take note on Harano-san point. Harano-san is also a very important colleague of us who is in the in this similar field. So he's our development engineer as well. So thank you, Harano-san.
He's responsible for the product. He's responsible for the product. So thank you very much, Harano-san.
Thank you very much for support. So ladies and gentlemen, you see we have Roy here. We have our support from our Japan side. So if you have any questions, send over here, and we're very pleased and we're very happy to answer. If we can't answer for you, we have Harano-san over here. All right. So I think I have another question. Okay, this is from Doran. Thanks for the presentation, Roy. Can you please advise when the user manual, datasheet, and spec will be available online? I think it should be available, right? I think the landing
it's already available, I think, yeah.
Yeah, so Doran, if you can actually log on to www.hioki.com. I do remember seeing the PW8001 landing page is already created. So you will be able to find the user manual, datasheet, and spec online. But in any case, if I'm wrong, all right, you can also send us an email to Hioki. I think you should be from Europe, so you can actually send an email to Hioki Europe to take note. Right, Harano-san, if you're here, am I right? Okay, so this is okay. So let's see if there's any other question from the chat, because I have some colleagues putting on. Okay, this is from Elmer. Gaining 5 megahertz to 10 megahertz is a tremendous increase. Yes, that's right. So this is a piece of good news. So we can, in fact, our equipment can even measure more and, to cover the requirements or even exceeds the requirements of the current industry. Because what we are planning now is in the future generation of the power measurement systems. So our engineers always see. They actually plan in the long run what they expect will be coming, or what difficulties or challenges will be coming in the near future. Okay, so let's see, is there any? All right. So ladies and gentlemen, feel free to post more questions. At the moment now, I don't have any questions. But at the same time, Johnny, I hope that we have managed to answer your questions between PW8001 and PW3390. Although we can't go in depth, you can take a look at the brochure first. Otherwise, you can drop us an email and we'll be very happy to connect with you. Or in fact, our engineers will be very happy to bring out PW8001 to share with you. Yes, Johnny say thank you both. Yes, thanks, Johnny. Okay,
Our
so
pleasure.
Yes, our pleasure. All right, so ladies and gentlemen, I don't see any questions coming in, but it's probably the in case if the topic is too heavy for you and you are still digesting some of the information, not to worry. Like I mentioned to you, let me repeat myself again. My colleague Jessie has sent in the latest catalog of the PW8001, the PW8001 landing page. So feel free to take a look over there, and you might need some time to digest the information. Like Roy has mentioned, some of the existing challenges like over voltage, and also you need more channels, and also the dual inverter system is probably already in place. But SiC and GaN is a very new technology which we really foresee in the next few years. This will be becoming an upcoming trend. There are also industries that's already using SiC and GaN. That's why we find that it's important to share with all of you here. Okay, so we have colleagues, we have distributors from Vietnam, colleagues from Vietnam, distributors from Indonesia. Thank you so much. Yeah, they are sending their appreciation to Roy as well. Thank you so much. We still have some time. If not, all right. So if not, ladies and gentlemen, if I don't see any questions coming, don't worry. All right. We will be dropping you an email on the recording, and also on the to follow up on the materials, the slide materials as well. So if you need to have any questions, if you have any questions, feel free to reply to that email. And also, ladies and gentlemen, we have the survey actually prepared at the end of this Zoom webinar. So after you leave this webinar, there will be a pop-up browser that you can actually fill in a survey. This will really help us to improve ourselves. We constantly review on the outcome, the responses of all your survey feedback in order to improve better. And for Singapore engineers, I think I missed out one point. This webinar is actually allocated 1 PDU points for those under the Professional Engineering Board. So if you need to get the points, we will be submitting the points and attendance for you. All you have to do is after you exit this webinar, the survey form, we will actually prompt you to key in your PE number. So please send us your PE number so that we can actually register the point system for you. All right. So thank you so much. I think we see a lot of customers, friends sending all the appreciation. In fact, we would also like to thank you for attending. Without your questions and support, this webinar wouldn't be that successful. Of course, I would also like to thank Roy for taking his time. I know it's pretty early. In fact, ladies and gentlemen, if you're not aware, he has been here with us since 8:30 in Europe timing.
No, but that's not a problem. No.
Thank you so much for sharing.
Yeah, and I enjoyed it very much, and I'm happy that so many people have joined, and that we have had several questions. So I think it was a good session. Yeah.
Right. I think from Elma, we should have more shared webinars together with other subsidiaries. That's right. So in fact, this is the first webinar together with Europe. We are looking forward to bring more. I think Europe marketing in charge, Oliver, is here. I can see him. So Oliver, this is a comment, a feedback from the participants here. All right. Thank you so much. We will consider that point, and we will definitely bring more good webinars to all of you. Okay, so if not, ladies and gentlemen, thank you so much for attending with us this morning, this afternoon, or even this evening in Australia. We hope that this session has been beneficial to all of you. So please stay tuned and wait for our email to be sent out, and you will be able to view the recorded webinars again for you to digest some of the information. Okay? All right.
Okay.
I think, sorry, Doran said user manual is missing. All right, Doran, thanks for your feedback. User manual is missing. Okay, so we have your email. Allow us to check with our headquarters, and our Europe colleagues will be following up with you on the user manual. We have your email. Not to worry, because you have registered with us, so we have your details. So Doran, point taken. We will follow up with you on the materials, the user manual. All right. Okay. All right, so thank you so much, ladies and gentlemen. Please stay safe and take care, and we'll definitely see you soon. And Merry Christmas in advance.
Okay. All right. Thank you very much. Bye-bye. Bye-bye.